To perform white box testing, okay, so we need to actually represent the control flow by using either a flow chart, as you can see on the left side here, yeah, or a flow graph, yeah, on the right side here. This is a flow graph, this is a flow chart. An equivalent of this flow chart is this flow graph. So a simple control flow we can actually illustrate or represent by using just a flow chart, okay, in which every single entity that you can see here is representing either a decision box or a statement, yeah, a process. And then in a flow graph, yeah, we simplify, yeah, the representation. So a flow graph should be drawn only when the logical structure of a component is complex. Yeah, for example, if you can see, as you can see here, it has only nodes, yeah, the circle here are the nodes representing the nodes, and then there's the numbers inside the nodes, yeah, that represent the activity or the sequence or the statements, not the sequence but the statements. For example, here statements 2 and 3, yeah, has been combined into one single node. All right, and then there is H here, that linking between the nodes, and then there is what we call as the region. Okay, there is a region here. Region here is the area, yeah, denotes the area. So if you can see here, there is 4 regions for this particular flow graph. This is the first region from here, okay, until this one, and this is the second region. This is the third region, right? So it's bound is the boundary you can see is the edge, yeah, that what make up a region, and then the outer region is also another region. So that is 4 region. If you wanted to see from the point of view flowchart, yeah, there are this one, yeah, and this one, and the outer one, right? So flow graph actually allows you to trace program paths more easily. Okay, so basis path testing, yeah, is actually a white box testing technique. Yeah, white box testing technique proposed by McCabe. Yeah, that it was this is actually an old testing technique. It's been there for so many years. What is the concern of basis path testing is that we wanted to identify the independent paths so that we can actually design the test cases to test each of the independent tasks and independent paths. So what is an independent path? An independent path is any path through the program that introduces at least one new statement or new condition. Okay, any path through the program that introduces at least one new statement or new condition. So for example, if we see from this program, there are 4 paths, yeah, and when we say independent path, it has to be a unique path. Okay, a unique path. So one path, for example, connecting 1 to the end node, right? And then second path, for example, connecting 1, 2, 3, 4, 5, 10, 1, 11, right? And so on and so forth. So it's an individual, unique path in the program, right? So this 4 parts is considered as a basis, yeah, basis set, yeah. So if tests can be designed to exercise the basis set, yeah, we can guarantee that each of the statement, yeah, will be executed at least once. This is the objective of white box testing. We want to ensure that each of the statement inside our source code, yeah, will be executed at least once. And it's possible only if we can identify the unique individual path. And every condition will be executed on its true and false side, of course. Yeah, if there is a condition, we will go both. For example, here you can see the third path here. Yeah, 1, 2, 3, 6, 8, 9, 10. Yeah, 1 and 10, 11. All right. So it's going to check both sides, the true and the false. Yeah, this is the decision node. Okay, so now by using this excuse me, basis path testing, how many paths? How do we know how many paths do we actually need to go through. First of all, to identify the number of parts, we need to know the cyclomatic complexity. So we need to calculate the cyclomatic complexity. So it refers to the quantitative measure of the logical complexity. So what is that? So cyclomatic complexity defines the number of independent paths to test for complete statement or branch coverage. So to calculate a cyclomatic complexity, which is the number of independent paths to test for a complete statement, is quite straightforward. Okay, there are three approaches. The first one is that we can count the number of decisions, simple decision. So how do we know the decision? So simple decision can be seen by this diamond box. Now this is a decision box. So how many decision box in this example? There is one, there is two, 1, 2, and 3, right? So 3 decision box plus 1. So that is the cyclomatic complexity, or represented by V of G. Okay, V of G. So that is a 4 here. Okay, so the cyclomatic complexity for this flow chart is 4. Another way to calculate the cyclomatic complexity is by now calculating the number of enclosed areas or the region. Okay, enclosed areas. For example, here the enclosed areas, there are 1, 2, and 3. Enclosed area only. So the outer region here is not counted. So there are 3 enclosed areas plus 1. So that is 4. So these are the 3 different formulas, yeah, to get the cyclomatic complexity. So as I said again, to perform this basis path testing, actually we can apply it at the source code level as well as the procedural design, in which we can see the flow chart. Okay, flow chart, or the what is that, another one, flow graph. Yeah, so V of G is the upper bound for the number of independent parts for complete coverage. So we identify now, firstly is the cyclomatic complexity. Yeah, since there are 4 here. Yeah, that means actually we need to identify the independent parts, which is equivalent to the cyclomatic complexity number, right? So we can derive the independent parts here. Knowing that there are 4, yeah, the cyclomatic complexity is 4 for this particular flow chart. Okay, now we can find out what are the independent paths, right? So there must be at least 4 here, 4 paths. Yeah, 4 unique paths, right? So for this one, it's very easy. You can simply trace from the flow chart, right? For example, the first path is 1, yeah, 2, 3, 6, 7, 8. This is the first one, right? And then pass to 1, 2, 3, 5, 7, 8. Second. So you see, it goes to this first path and then second path. Path number 3, 1, 2, 4, 7, 8. And path number 4, 1, 2, 4, 7. And then it potentially goes back to this looping, yeah, condition, 2, 4, and so on and so forth, right? So we finally we should derive a test cases to exercise this path. So when we design the test cases, it has to cover all these individual paths. Okay, so yeah, that is 3 enclosed areas. Yeah, if you look at this flow chart, this is the same example. Yeah, the second enclosed areas, the third enclosed areas. Of course, the cyclomatic complexity is enclosed areas plus 1 is 3, plus 1 is 4. Okay, so cyclomatic complexity, a number of industry studies have indicated that the higher cyclomatic complexity, the higher the probability of errors. Okay, so the more value of V of G that we obtain, the greater the value of cyclomatic complexity, the higher possibility, yeah, for us to find an error in the codes. Right, so cyclomatic complexity indicates a likelihood of yeah, the volume of errors. So that's why we can focus the testing only perhaps on the critical module or critical functions. So we can, because otherwise it is taxing, yeah, it is taxing to perform white box testing if we were to consider each individual pass. Right. So other than the flowchart, flow graph, yeah, we can also actually checking the basis path testing from the source code. Yeah, if we look at this source code, yeah, we can represent this in the form of this flowchart. Right? Sorry, this is a flow graph. Yeah, flow graph notation. Right. So for example, in this one, obviously we can easily calculate the cyclomatic complexity first by calculating the enclosed area. This is the easiest one. The enclosed area, there are two in this case. This is the first one, and then this is the second one. So 2 plus 1 is 3. So that is 3. So what is the independent path here? Yeah. So independent path, there must be 3. Yeah. Alright. So actually, we don't need a flow chart, but a picture will help you trace a program path. So because basis path testing is quite taxing, basically. If we have a huge module, you can imagine, yeah, if you have lots of control structure in our program, lots of if else statement, lots of for loop statement, lots of do while loop, you know, the white box testing can, to a certain extent, can be complex. All right. So basically, it is advisable for us to perform the basis path testing only for critical modules. That's why we need to know the cyclomatic complexity. So we don't waste time to actually checking a simple condition like if else. Okay lah, we can, you know, omit that. That very simple testing. For the sake that we wanted to focus more effort in the critical modules that have a larger complexity, cyclomatic complexity. Right? So I leave this as an exercise. I will give you as an exercise. Yeah. For example, if you are given this flow graph, so how do you determine the cyclomatic complexity? How do you determine the value of V of G? Yeah. How do you know what are the basis set of independent parts? Okay, so I will leave this as an exercise. All right. So next, another way to actually compute the cyclomatic complexity, we can perform using graph matrices. Yeah, graph matrix is a square matrix whose size, which is the number of rows in column, is equal to the number of nodes on a flow graph. So it's very easy, yeah, if you wanted to identify cyclomatic complexity by using graph matrices. For example, if we have this flow graph, yeah, connected by all these nodes, so we can represent it in the form of rows and columns. So the same nodes, so there are 5 nodes over here, right? And then we will see which node is connecting to which nodes, right? So let's say, for example, node 1 is connecting to node 3, right? So there's a connection here. So we can see that there is one connection. And then there is no linking from 2, but node 3 is connecting to node 3 is connecting to node 2 as well as node 4, right? So here you see the arrow here, okay, the arrow connecting to. So that is, there are 2 here. There are 2 connections. So in the end, you total it up, right? For example, there are 1 minus 1, 0. So you have to minus 1 for each of this total connection. And then 1 plus 1 plus 1, the total is 3. So 3 plus 1 is 4. So 4 is the cyclomatic complexity value of this flow graph. So this is just another way of representing, calculating the cyclomatic complexity by using graph matrices. Yeah, actually this is the same thing as what you see on the flow graph. Yeah, it's much easier actually to calculate the cyclomatic complexity by using a flow graph as compared to the graph matrices, unless there is a software tools, you know, that it can be easily calculate. You can use to easily calculate the value. All right. Okay. So in summary, to derive the test case, you must use the design or code as a foundation, and then draw a corresponding flow graph. All right.